All right. Bismillah Rahman Rahim. Uh, let's start with this topic of friction, which is called the regimes of motion during the dry friction. Okay. So there can be three cases of this regime. Number one, the case one will be no motion and the object is in static equilibrium. Number two, it is the impending motion. And number three, it is going to be the object is started in motion. So there are three different scenarios. Okay. The first one is no motion and the object is in static equilibrium. Okay. So if you look at this figure, the force of friction F will increase. If you look at figure, as the applied force P increases. If you look from here, from this diagram, this is the force and this is the applied load P. Okay, this is the force of friction. This is the force of friction over here. What he's trying to explain you over here is that this y-axis is basically the force of the friction. The horizontal axis corresponds to this force P. Okay, we call it F, or this F equals to P. So what we see in this figure 1, he is trying to say the force of friction F will increase as the applied force P increases. Okay, so as we increase this force P on the body, this force friction will also increase in order to stop this body from moving. That is the main reason it increases. And then it says because it increases from this point, it increases until unless it reaches to this point. And this point, if you look at it, is the maximum possible point that the object can uphold. So if you look at it, you have reached this maximum point. So again, this tells you that once the body reaches to this point, okay, this is the called as the impending motion point. If we are basically before this point, this tells you that there will be no motion. Okay, once it reaches to a point, this is the maximum frictional force, static friction force that the object basically can uphold. Okay, so you can very easily say that if this point, if you look at it, you can very easily say this point is the maximum. Okay, here if you look at it, your Fs will be maximum. Okay, just remember this point. And just before this point was of basically no motion. Okay, and if you look at it, this is Fs. This is Fs. Once you go just once you move from this point, you see that the value of the friction starts to decrease. Okay, well, this thing, if you look at it, the frictional force starts to decrease. Okay, the reason being that once you cross this point, this one, okay, the frictional forces tends to decrease as the object starts to move. As this object starts to move from this point onwards, definitely as the motion is there, the friction will reduce. And from here the Fs equals to mu Sn will not hold, and now as we go from this point, we will be saying it as Fk will be equals to mu k into n, because from this point the object has already started its motion. So very important point here, this is a very important point. The drop in the curve is due to the fact that it is relatively easy to keep the body in motion once it has started to move. Okay, so this is a very important point. And all this zone, if you look at it, all this zone is the zone in which there will be no motion and the object will be basically equilibrium. And very important point, in this zone your basically the frictional value, the frictional value in this zone will always be less than the maximum frictional value, which is mu Sn. It will always be less than this value, remember. And whatever friction value will be in this zone will always be, as you can see, it will always be less. And this is very important, this is F is equals to P. This force P is basically being represented as basically the force which is creating the motion, and this it is being also equals to F. Okay, not Fs but F. So this point you already know. I have discussed how to calculate this x. This x is basically equals to remember ph upon w, and this is once it is being done, x is basically the point. If the body starts to tipping, we have already discussed, this x value will be basically it starts from this point, and if the body tips, this distance will be x if the body starts to tip. Okay, this is already being explained. Okay, so very important. Then again what about you remember this R? This was the reactive. This was the reactive component. Remember R? This was the reactive component. It was the reactive resultant. Remember? Okay, this is the normal reaction, and this is Fs was the frictional force, and this reactive resultant was basically it will be making an angle phi s with the normal reaction. But what is phi s? Phi s is basically called as the angle of static friction. What is mu s? It is the, if you look at it, what is just wait, what is going to be our mu s? Mu s is a measure of degree of mu s is the coefficient of static friction, a measure of degree of roughness between the mating surfaces. Okay, and it is always experimentally measured, and the value of mu s is always, this is the coefficient of static friction, and it is the contact between the two metals. Metal on ice, it will have this value, wood on wood this value, leather on wood this value, leather on metal this value, and aluminum on aluminum this value. So it is being measured, calculated experimentally, and then again this all Fs and phi s, remember, will always be till this domain. It will always be this domain and below that. Once you are in this domain, you will not be using phi s, because the body started to move. Now you will be using the equation, this one, F is equals to mu k into n, and for this the angle of friction will be called as, it will be called as the angle of kinetic friction, which is termed as phi k. So phi k is what? Tangent inverse of Fk upon n. It is given as, again, tan phi will be equals to Fk upon n. Over here it was tan phi s was basically given as Fs upon n, as it was tangent theta. Okay, so Fk is what? Fk is basically mu k, and you can put it over here divided by n. So you will get phi k is equals to tangent inverse of mu k, as if you want to calculate phi k in the body, and if you want to calculate phi s, it is tangent inverse of mu s. And this is the angle of kinetic friction, phi k. And what is mu k? Mu k is the coefficient of kinetic friction. Okay, mu k is the coefficient of kinetic friction in the body. So again, this is a very important concept, and because this graph is very important. This graph plays a very pivotal role in understanding the regimes of motion. Whether if the body is given as you can call this as case 1, this will be your case 1, this will be your case 2, and if the body is in motion, this will be called as case 3. Okay, we will discuss the cases one by one. So remember, this is the equilibrium zone. The body will be in the equilibrium. This is the equilibrium zone. Okay, the body will be in equilibrium, and why? Because the frictional forces, the F will always be less than the maximum frictional force mu s n. Okay, so we shall stop here, and we'll go for another case. Start with case 1.